Okay, so we start our week 8. This week we'll be talking about databases. And I want to spend on this topic 2 weeks. Today I will show you the hard way, working with SQLite, pretty low-level code. And next week we'll introduce the framework that Android started some time ago that give you some abstraction layer, right? So you don't have to type in all the SQL queries and stuff like that. But because many examples that you can find in tutorials and stuff like that still use the SQLite and still is using SQL queries, that's why we will start with that.
What do you think about Firebase with Android apps?
Well, we can have this discussion later on, right? It's a different thing, right? This is a relational database. Firebase is NoSQL database. They can be used for totally different things, right? The purpose of the database is different. So we can have this discussion at the end, okay? So I'm creating a new project. Same way that I did before, right? Empty activity. Finish. It is working on the build. To introduce you to what we're going to do and why this is the hard way. It's a hard way because you have to write lots of boilerplate code, lots of code before you can get stuff working, right? And we'll create several classes today. We'll start with defining our model. Simple class that will represent the post. So title, content, and ID, right? Based on that, we'll create a contract, and contract will be a description of tables. Then we'll create DB helper class, and that will be the heart of the system, the class that is really sending the queries, processing the results. And only after that, we'll be able to really use the database in our activity, right? So our activity will be simple. It will just show one record, not much, right? But you will see the steps that you need to do to achieve that, right? And next week, we'll introduce the framework, and we'll do a little bit more with the database, right? So let's start. Let's fix our issues that we fix every week with the style. We'll use this layout with minor changes. We'll use this layout with minor changes. I will use the label that I have as an output. I will just make it a little bit wider so we can show more code. And I need to add ID, and ID will be out. So output, right? That's the element that I will use as my output. I want to show just the content of the post, right? So I'm not really building any UI this week. Where do we start? We'll start with creating few classes, not activities, just regular classes. And the first one will be called post. This class will be my model, right? This class will be used to represent a single post. It will have 3 members, private, long, ID, string title, and string content. Now using IDE, I can generate everything else that I need in this class, meaning the constructor and getters and setters, right? Because the fields are private. Right click, generate. Let's start with the constructor. I want two constructors, one that has all the fields, so I select all of them from the list. And the second one that has only title and content. And in this case, ID will be set to -1 to indicate that this is not object from the database. Another thing that I want to generate, getters and setters. Again, I'll select everything from the list, OK, and I have the class ready. So the only thing that you have to type are the fields, right? The definition of the class members. Everything else you can generate. Ready? Can we continue? Yes, no? Yes? OK. Now let's create another class. Let's call this class post contract. The public class, but it should be final. This class will not be instantiated. We could make it abstract, or we can make the private constructor. Class will have another class inside, public static class post entry, and this class will implement base columns. Base columns is an interface that provides us with some definitions required by the database. One of them is, for example, ID field. It has a proper naming, and this name is used later on or expected later on when you're processing the database using classes. So that's why we are using this. And this post entry will define the fields that we'll have in the database, and it will also define the table name. So I will have a few constants here. Public, static, final, string. First one will be table name, and it will be called posts. Now I'll have columns. Call, name, title, and content. I can also define types here. Right, so I will have call type, title will be text, type, content will be also text. I will extend the contract class later on, adding also definitions of some queries. And two queries that I want to add right away are the query to create the table and query to drop the table. Right? I will add it to the contract class. SQL create table, create posts. Basically, what we are doing here, we're building a standard SQL query, right? So create table. The table name is post entry dot table name. Open the bracket. The first field will be post entry underscore ID. This is something that we get from the base column interface. This will be an integer and the primary key. The second field will be title, so column name title plus post entry column name, column type title. This is the type of the column. And the last column that we'll add is the content. And we can close the bracket. Remember about the spaces in your strings, otherwise it will be all clustered together and it won't be a correct SQL query. So that's the query to create posts, and now the query to drop the table. SQL drop posts. Drop table if exists. And we need to add the name of the table, which is post entry dot table name. This query is quite simple. The next step will be adding the DB helper class. Let me know when you're ready. Ready? Okay, so let's create a new class. Java class, post DB helper, the name of the class, and the super class for this one is SQLite open helper. You can see the type better here. We have to add a few things to this class. Specifically, we have to implement the missing methods. And there are two methods that we have to implement, on create and on upgrade. Another thing that we have to add is a constructor. Constructor will add manually, will be public constructor post DB helper. It will take one parameter. It will take only context. This constructor will call the constructor from the superclass. But to do that, we need two extra pieces of information. And we'll control these two pieces through the constants. We'll define two constants, public, static, final. Int. The first piece of information is the database version. DB version. We'll set it to 1. The second piece is, as you can probably guess, the database name. All right? Static, final, string, DB name, post.db. Now we can call the super. Context, and the database name, null, and database version. We are not using factory. We could, but we are not defining a factory. Factory is a class that can create objects for your models, right, based on some parameters. We are not using that. So we have the constructor. Now let's focus on create. On create will be very simple function, because the only thing that it will do right now, it will be simply creating the table, right? So we'll use the reference to the database that we get as a parameter in onCreate, db, and we'll execute query, exec SQL. Which query? The query from the contract. SQL create posts. Done. On upgrade, we'll do something that normally, if this is the database that is keeping some user information, some user-generated or gathered data, we shouldn't do that. The only context, the only use case when you can simply drop and recreate the database is when it's only as it acts only as a cache, right? So don't do this unless you use DB as a cache. What we'll do here, again, we have the DB, we'll execute query to drop posts, and then we'll call onCreate. Right, this is recreating the database. Just for us to see when those methods are called, I will add the log, the debug call here. db test database created. And upgraded. As you can see on upgrade, with the reference to the database, you also receive two integers. First one is the version of the database that is currently installed on the device. The second integer is the version that is coming with the new version of application. And I will add two more functions to the DB helper class. One function that will select one post based on ID. The second function that will insert a new post. Let's start with insert. Public long will return the ID of the newly added post. Add post. Two parameters. The first one, SQLite database DB, The second one will be a post. The interface that we are using, the API that we are using, is fairly flexible. You can write down the whole query as a string, or you can construct the query. And I will show you how you can construct the query. First, we need the content values. It's a class that basically is a map, it's a dictionary, right? The label and the value pairs are stored in it. Call it values, new content values. Now let's add elements that we want to put there. The first element in the pair will be the name of the column. So post entry dot column name title. And the title from the post. The second value that we'll add will be the content, right? Put post entry all name content post dot get content. I'm not setting ID because ID is a primary key and it will be auto-incremented in the database. So we'll get the new ID as a result. Now I will use the DB to insert new element, post contract, post entry, table name. This is the table where we are adding new row. We don't use any hacks. There is no extra code that is executed on insert, and values is the representation of the code of the row that we want to add, right? This function returns the ID of the newly added record, and that's what we want to return from this function. And reading from the database will be similar. Again, we'll construct the query. We'll construct the SQL select. Let's add another function. This function will return a post, a new object. I will call it get post. Again, it will get the database as a parameter, and the second parameter will belong ID. Post ID. We'll return null if we don't find anything. Let's try to find something, right? So we have the reference to the database. Now let's define pieces of the query, right? If you recall SQL, you have projection, so the list of fields that you're selecting from the database. You have selection, that's your where clause. In this case, it will be divided into pieces. First one will be the definition of the where clause with the parameters replaced with question marks. The second one will be the array that will have values for those question marks, right? And then you can have a sorting order. You can have the group by defined in a similar way, also having defined in that way, right? So let's start with the projection. Projection is an array of strings. And in this array, we'll have all the fields that we want to extract. So post, entry, ID, post, entry, title, and post, entry, content. Writing the query, you would say select underscore ID, title, name, from, and so on, right? Next step, we have to define our where clause. Define it as a string. Post entry dot ID equals question mark. Now the parameters for those question marks are defined in the string array. In this case, we have only one. Is the post ID. We have to represent this ID as a string, so that's why I'm calling long to string, right, to do the conversion. Since I'm selecting only one record, I don't have, I won't have sorting order, having, or group by in this query. So I'm skipping them, and I will pass null values to those parameters, right? I will execute the query, and this function returns a cursor. Returns a cursor, and the parameters that you have to pass to all queries, you have to pass the table name, right? So post entry table name. Second parameter is our projection, then selection args, selection args. Then you have group by, which we don't have, so it's null. You have having, another thing that is empty for us. And then you have the sort order, which is also empty in our case. We won't sort the one record that is coming from the query. So this is executing the query. You get the result in a cursor. Now we have to check if you got something, right? If you expect more than one record, you would process everything in a loop. cursor has a function that tells you if there is a next record, right? So if you go to cursor, you have move to next. Function returns Boolean, true if there is a next record, false if that's the end. We expect only one record. So what we can do, we can move to first, and we can do it in an if statement, right? So it will be if move to first, and we have something, right? We'll create a new post. To create a new post, we need parameters, right? We need to extract information from the cursor. First element will be ID. This ID is long. Cursor dot get long. This function expects that I will give the index of the column. ID should be first because I defined that order in the projection, but there is no guarantee. The best way to make sure that you're using the proper indexes is to ask cursor what is the index of the given column. So cursor dot get column index or throw post entry ID. This function is giving me the proper index, or there will be an exception. And this function is giving me the value for this column, right? So I have my ID. Title, same thing. Different function, get string. And then we have to check what is the index of the title. Break this line so you can see entire thing. Content will be very similar. Different name, right? Now I can use these three values to create a post. It will be ID, title, and content. This post is what I return from my function. One thing that you should remember about the database SQLite is the fact that the database code is triggered, the construction of the database is triggered not when you install the application, but when you first time try to use the database. If I run my code right now, the database will not be created because I didn't attempt to access the database. The trigger is the first time when you try to access the database. Then the code is executed. Why this worth remembering is if, in case you want to preload the database in your application, there will be a delay, right? You will add some extra time to the event. What I will do right now, actually, I will use this function that I added here, the insert function, right? Add post. And I will trigger this function right after the database is created. So I will add an initial post. Okay? So I will call add post, new post. The title will be post 1, and the content will be, this is my first post. It's complaining because my because I didn't pass the database. DB should be the first parameter, right? I'm adding a new post when I create the database. So now it's time to use it, right? So let's go to the main activity, finally, first time today. I need two things. I need to create the instance of the DB helper. Post DB helper, new post DB helper this. Activity is a context at the same time. So I'm passing the context to the DB helper. Second step, DB helper will give me the reference to the database. All right, so SQLite database DB is equal to DB helper dot get. Now get what? I have two options. I can get reference to the readable database in case I just want to read the information. I don't want to modify the information. Or I can get the full access, right? Get writable database. Writable also includes the readable part, right? And that's the one that I will request. All right. What I will do right now, I will ask for the post DB helper dot get post DB 1. What I will do with this, I will display the content, right? So I will get the text view and I will display the content of this post. To make my life a little bit easier, what I will do in the post, I will add function to string. It will format the content, right? So I will have ID plus title plus content. This way, I can use this information in the main activity. Right? I will say out dot set text p dot toString. Finally, I can test something. I will open the logcat. DB test was my tag that I used. I will run a new device. That's old output. If you think about what it is, this is old output. Now we have the new thing. What happened? Seems that our insert didn't work correctly. Let's see. Or the selection didn't work. Let's debug. Let's see if we have anything there. Seems that the insert didn't work. Let's see. clean our data from the phone, and let's try to run it one more time. Maybe the conflict with one of the previous versions of the application that I was building and testing with other groups. Okay, I see where I made a mistake. Sorry. I've added this line, add post, on upgrade, not on create. And nobody's yelling at me. This should be here. Okay. Let me clean up the mess. Let's uninstall this application. And I was thinking what I'm doing wrong. The selection should work right now. Right, so you have title 1, post 1. Now, if I run it again, there'll still be only one record in the database. This code on create, this code is executed only once. When you first time try to access the database. On upgrade, it's executed only in the situation when the new version of the application brings the new version of the database. Notice that these two things are independent. You can have a new version of your application, new release of your application, but since you're not changing the database structure, the database version may remain the same. And on upgrade will be dormant, right? You have the database version defined here. And whenever you increase this number, say number 2, this code will be executed. Let's see, logcat v test. if I run it in a debug mode, we should stop here. Right? I mean, on upgrade, and then from on upgrade, I go to on create, and I recreate the database. I'm adding new post. What you see in Logcat, the database was created. If I run it, if I modify the version of the database, right, we stop here. The old version is 2, the new version is 3. And in Logcat, you see that the database was upgraded. So if we have the situation like the one I mentioned in the beginning, right, that our database is only a cache. So you have a stable database somewhere, in most cases on your server, right, and you're just downloading a snapshot from the database. This approach is okay. What happens if this is your operational database that you want to use on the device? So let's say a user can collect some information in this database. Obviously, you don't want to drop, right? What you should have instead in your code is a series of scripts that are bringing the that are altering the structure of the database, right? So, for example, my old version is 1. The new version is 3. I should have scripts that are bringing me from 1 to 2, from 2 to 3, right? So incremental changes that that you've been doing in your design, right? You want to avoid the situation when you drop the database and lose all the information. Now, updating and deleting information from the database works in a very similar way that adding, so inserting and selecting works, right? If you want to delete, you have to define the selection part of the delete query, and you have to call the function delete. If you want to update, it looks very similar to your insert. You define what are the changes using the content values, and then you define the selection, so which rows are modified. And there is a function update in the DB. One thing that I forgot to do, and again, this is a mistake that right now we didn't notice any issues, but if my code would be doing that a lot, at some point my application would crash, is lack of close statement in my selection. I created the cursor, it was opened, I tried to extract some information. So there are resources that are allocated. I should close it to release those resources. If I keep adding new cursors and all of them will be open, I will be in trouble at some point, right? Memory-wise or handler-wise, I won't have access. I can lose access to the database at some point. Right, so we should do that. Now, also the opening and closing the database is expensive, right? So when you open your database, as we did here, we want to keep it open as long as possible. So what we should do, we should modify our main activity, right? Instead of keeping this as a local variable, this should be my class member. I should open it on create, and then on destroy, before, I should say that I want to close the database, right? And the closing is done through the DB helper, right? So I'm moving the DB helper up there as well, right? And I will say DB helper dot close. So I will now stop the recording, and we can have some discussions in class.